Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem duplicate subtrees. Previously, this problem has been asked in companies like Amazon. So let us discuss the problem statement and see what we can do in order to solve this problem. So problem says that you will be given a binary tree which will be consisting of n nodes in total. So the size of the binary tree will be n. Total n nodes are there. And your task is to find all the duplicate subtrees from the given binary tree. Now, what is a subtree? Basically, subtree is a part of the tree which is contiguous in nature. So, for example, if you will see here, so 2, 4, like the subtree starting from 2, which is including 4 as the left child, it is a subtree. Then subtree starting from 2 till the node 4, it is also a subtree. Now, if you will see the subtree, which I'll highlight with this color, subtree 3, 2, 4 and 4, it is also a subtree, because whenever you start from a particular node, then all the children that are coming in the left subtree and the right subtree, you will take all the part. That is known as a subtree here, right? Now, after this, if you'll observe, so we have to do what? We have to store all the nodes which are making duplicate subtrees here. Okay, now what is a duplicate subtree? So basically, you can see here that I have highlighted two kind of subtrees here. Okay, one subtree is the subtree that is having only the node as 4. Okay, because 4 is repeating multiple times. 4 is being repeated 3 times, so 4 is duplicate. Okay, whenever a subtree repeat more than once, right, whenever a subtree is appearing second time, then you can store it. So 4 is appearing 3 times, so you will store it only one time, right? Then you can say that the subtree 2, 4, it is appearing twice. It is also duplicate. Okay, it is present more than once. So you need to store the subtree 2, that is, you need to store the subtree which starts from the node 2. So indirectly, you need to store that particular node 2 as well. Okay, so this is what you need to do. Now, one thing that is very important here is that there can be multiple ways of generating a subtree, but what is the very normal way? So let's say if I have been given a diagram like this, let's say I have been given a tree, let's say 1, then I have got 2 and then I have got 3. Now, how do I make the subtree? Like, how can I decide that I can declare I can store this subtree? So basically, there can be multiple ways, but what I can say is that I'll first of all store the left part. Okay, then after that, let's say I'll store the right part, and then after that I'll store the root data. Okay, if this is how I start storing the tree, so let's see how it will look like. First of all, whenever I'll be at a particular node, I'll go to the left, I'll call for the left subtree. Okay, so I'll go to the left, I go here. Now the moment I go here for 2, so when I call on the left of 2, it is null. So when I get null, I'll return from here. I'll return, like, I'll not do anything, I'll not update anything. Then after this, with respect to 2, I'll call on the right as well. When I call on the right, right is also null. So since right is also null, then I go back from here. Now the moment, like next time I am at 2. So you can say that indirectly I'll add this root node guy. So it will be basically 2 here. Now I'll go back here. When I go back up, then for 1, I'll now call for right. So when I call for right, I'll call for 3. With respect to 3, when I call for the left, it is null. So I'll return back. Okay. With respect to 3, when I'll call on the right, so it is null. So I'll return back from here. Now I'll store 3 also. So 3 is also stored in my answer. Now after that, when I'll go up, so what will I do? You can see that the left subtree was basically 2, right subtree was 3. You can see left was 2, right was 3. And then I'll add the current root value. So the current root value is 1, so I'll add it. So you can see that I'm able to represent it like 2, 3, 1. Okay, but there is one catch here. Because if you will see, let's say I have a tree which is something like this. I have got 1, 2, 7 and then 3. Okay, and then I've got what? I have got 1, 2 and then 73. So if you will observe this kind of a test case, what will happen? First of all, I'll store the left subtree. I'll store the left part. So I'll store 27. Then I'll store the right part. So I'll store what? I'll store 3. And then I'll store what? I'll store the root. So I'll store 1. If I do it, then this is the string that I'm going to generate. I'm going to get 2, then 7, then 3 and then 1. Now similarly, if you'll observe, if I do the traversal for the second tree, so the left part is 2, then the right part will be 73. So I'll write 73 here. Then the root is 1. So I'll write 1 here. Now, if you will see, the strings are looking same. This string and this string are looking same. So does that indicate that both the subtrees are same? Actually, they are not same, because if you see, with respect to 1, the corresponding tree is also having the node as 1. But for 1, the left child here is 27. The left child in the other tree is 2. For 1, the right child here is 3. For 1, the right child in the other tree is basically 73. Okay. So if I don't use any separators for the left and the right part, then I'll be in trouble. So this is not the correct way to do this particular job, because if you'll directly store the integer values in a string format, so then you might end up saying that subtrees are same by looking at their strings, but actually they will not be same initially. So what you need to do is, let's say if I'll draw this diagram once again. So let's say we have got 1, then we have got 27 and 3. Okay. After that we have got 1, then we have got what, 2, and then we have got 73 here. Right. This is what we have got here. Now, if you will observe here, what will happen? If you will observe here, so when I'll be at first of all, we'll call for the left. So on the left, you will have 27. So you will store 27 with a hash value or with anything that is dot or any separator. So you can use a character, let's say hash. Then after that, the right part will be inserted. So right part will be 3. You will put it, and then you will put a hash, and then you will put the root data. So root data will be 1. That is how you will put it. Now after that, for the other tree, 2 will be there. Then hash, then 73. Okay, then hash, and then you will have 1 here. So you can basically observe, guys, that when we will generate the subtrees like this, that is the left part plus the right part, like plus hash plus the right part plus hash plus the root data. If I'll store it like this, then chances of making error are 0. Because earlier, if we were not using separators, then we were saying that the tree 1, 27 and 3, and the tree 1, then left child is 2 and right child is 73, they were same. But actually they were not same, because they were different, but in our case our strings were looking like same. So we need to use separators. After adding the left part, you put a hash, then after that you add the right part. After adding the right part, put a hash, and then add the root value as well. By doing this, you are always keeping a separator so that your strings are never matched if the trees are not exactly the same. Now let's say if we had another example which will be like this. Let's say I had got 1, then I've got 2, then I've got 3, and the other tree is also like 1, 2, 3. Now what will happen here? Now what will happen here is, if you'll see in the first string, so how will the diagram look like? Now in the first string, first of all, you will have 2, then you will have hash, then you will have 3, then you'll have hash, then you'll have 1. So first of all, you will call for the left part, you will get the left subtree, then you will add a hash, then you will put the right subtree data, then you will put a hash, and then you will put the root data. Same is the thing that will be done for here. So 2, then hash. Okay, then you will write 3, then hash, and then 1. All right. So you can see that this and this are same as well here, right? So basically both the trees are both the subtrees are same. So that is why they will show duplicacy in terms of the key value, right? Now let's say let's take the sample that was given to us. So let's say we have been given 1, 2, 3. So let's write this tree once again. Let's say we have been given 1, then we have been given 2 here. Okay, then we have been given 3 here. Okay, then we have been given what? We have been given 4 here. Okay, then we have been given what? We have been given this guy 2 here. Okay, then we have been given this guy 4 here. Okay, then we have been given this guy 4 here as well. So let me write this clearly. Okay, now if you will see here, what we are going to do is we are going to declare a map. Now how will our map look like? The map is going to store the string, and with respect to that string, how many times it is occurring, we have to store that. So we'll store integer. So basically we'll store the integer frequency of that particular string. Now whenever I am at a particular guy, so let's say I'll start with 1. Okay, when we start from 1, we'll first of all call on the left and the right, and then we'll add the root. So now we'll call on the left. So now left is 2. For 2, I'll also call on the left. So I'll call for 4. Now with respect to 4, when I'll call, so I'll be getting a guy null. Okay, from the left I'm getting null, so I'll get an empty substring. Okay, then after that what will happen? From the left I'm getting null, so I'm getting an empty substring. For the right of 4, I'm getting what? I'm getting null as well, so I'm getting empty substring. So left part is empty, then after that I'll add a hash. Right part, then I'll add the right part. Right part is also empty, then I'll add a hash. And then after that what will happen? I'll add the root guy. So I'll add 4 here. So this is the string that I have. Inside the map, what I will do is I'll mark its frequency as 1, indicating that this particular subtree is present one time. It is already seen. Now this is the node. Now after this we'll return what? We'll return the subtree that we have made. So from the left side we are getting what? We are getting hash, hash, and then 4. Okay. Now what will happen? With respect to 2, when I'll call on the right, so I don't have anything, so it is null. So let's add the left part. So the left part is what? Hash, hash, and then 4. Then right part is not existing, so you will directly add a hash here. Then the root guy itself is 2. So I have seen this particular subtree. Now inside the map, what I will say is that I'll update the frequency of this particular string as 1. So basically I've stored the substring, I've stored the subtree 2, 4 here. Now after this we'll do what? We'll go back up. So when we'll go back up, then the string that will be returned is what? Hash, hash, then 4, then hash, and then 2. Now we'll call on the right. So we'll call on the right, we'll call for 3. With respect to 3, we'll do what? We'll call on the left. So we'll call for 2. Now with respect to 2, we'll call on its left, so we'll call for 4. Now when we are at 4, its left is null, so left is null, so we'll not add anything in the left part. Left will be empty plus hash. Then right part is also null, so nothing will be added, empty plus hash, and then the root guy is 4, so you have got 4. Now if you see, this particular subtree is already present inside the map. It is already, its frequency is 1 already, so this means it is repeating. So inside your answer, what you will do is, since this is repeating, so inside your answer of nodes, you will store the node 4, that a subtree starting from the node 4, it is repeating. So let us store it in our answer, because when I have generated this particular substring here, so its frequency is already 1. So this means that it is already present, so we should say that it is coming for the duplicate time, it is coming for the second time. So now let's store it in the answer. Let's store this node in the answer, because this subtree is repetitive, and let's update the frequency to 2 now. Now after this, what will happen here is, going further, now we'll go back and we'll return what? We'll return hash, hash and 4 here. Now what string will be generated? The left part is hash, hash and 4. Okay, the right part is null, so you will add empty plus hash, and then you'll add the node guy as 2. Now when you have got this particular data, that is hash, hash, 4, hash and 2, then in that case you can see that this string is already present inside the map with the frequency as 1. So this means the current string that I have got, it is a subtree which is repeating for the second time, it is duplicate. So I need to store the node 2 as well inside the answer, indicating that the subtree starting from 2 needs to be stored as well. So after this, I'll do what? I'll update the frequency basically to 2 here. So frequency of this particular subtree will be 2. Now when we go back, so then what do we return? We return basically hash, like we will return hash, hash 4 and then hash and then 2. Now when I call on the right, so for 2, like for 4, I'll call on the left. Left is null, so I'll get like empty plus hash. Right is null, so I'll get empty plus hash. Then I'll add the root guy, so that will be 4. Now when you have hash, hash 4 here, right, so it is its frequency is what? Its frequency is basically already its frequency is 2. So if its frequency is 2, this means that it has already occurred for the duplicate time. It has already occurred 2 times. Now it is appearing for the 3rd time in this case. So if it has already appeared 2 times before this appearance, so it must have been already stored inside the array. So we'll not store it again, because you can see subtree 4 alone is already stored in the answer, right? So this is how we need to do this. Let's try and write the code for our approach here. So what we need to do here is, first of all, we'll declare an unordered map here. So we'll declare unordered map of what? Of, let's say, string comma the integer. Okay, let's name it as MP. Now after this, what I'll do is I'll call the recursion, I'll call for the root guy. Okay, and then after this, at the end, we also want to store all the duplicate subtrees. So we need to declare a vector for nodes which will store the final answer. So vector node star, let's say, as answer. Okay, then what I'll do is I'll pass the answer here, and answer will be storing all the duplicate subtrees, and at the end we'll do what? We have to return our answer here, right? Now what will happen next? So we'll write string recursion, because it will be returning a string to us, right? So we'll write node star, let's say the root, current root that I'm at. Okay, then I'll also pass what? I'll pass the vector int ampersand answer here. Okay, now vector int ampersand answer will store all the nodes that are behaving as duplicate subtrees, right? So if the current root that I am at, if it is null, then I can directly say that we can do what? If the current root that I'm at, if it is null, then we'll directly return the empty string. Okay, otherwise what will I do? Otherwise I'll call for the string. Okay, and I'll call for the left part. So let's say this is the left part, so let's write it. For the left part, you will call the recursion for what? You will call the recursion for root.left, and you'll pass the answer here. Okay, then you will call for the right part also. So you'll write string, then after that what? You will write the right part will be equal to the recursion of the root.right comma the answer here. Okay, now after this we have to generate our string. So we'll do what? We'll say that string, the current answer, current key that we have to generate will be what? It will be basically the left part of the string plus a hash, that is a separator here for us, plus you can say hash, plus what? Plus the right part, as I've already said, plus what? Plus again a hash, and then after that what? After that we'll add the current root data. So since it is integer, so we have to convert it into string. So we can use the toString function. So we can write to__ string. Okay, and then we'll do what? We'll write the root arrow data here. Okay, so we'll add this, and then after that we'll check that if the inside the map, so I have not passed the map in the function, let me pass the map as well. So let's pass this map here in the recursive function, let's pass it here as well. So we'll write unordered %mp, right? Then we'll pass the map here, okay, and we'll pass the map here as well. Now what will happen here is, if the map has this particular key already, if it is already marked as 1, if it is already it's already occurred one time, so now it is appearing for the duplicate times to store it. So what you will do is, you will say that you will store inside the answer this particular node. So answer dot pushback what, answer dot pushback this particular current root node is what you will store, okay. Now otherwise if it is present multiple times, then that's fine, and then you can update the frequency as plus plus. So you after if it was already present one time, so you have added it because it is coming for the second time, and then you update the frequency every time, okay. Then after this we'll return this key, so we'll return the key, that is this particular generated representation here. Let's try and quickly compile this to check if it is working fine or not. I think it should work fine, okay. Currently it is giving some issues here, so instead of dot I have to use arrow in C++. So let's write root arrow, and let us write root arrow here as well. I hope that rest of the part is written correctly, okay. So I should pass answer as a node data type, so vector int answer should be having the node data type here, okay. Now it looks like it's working fine, let's see. So I've not declared the spelling correctly, let's correct it, let's compile it once again. It is working fine on the samples, because it says that for the given tree the subtree 2, 3 and 3 are repeating, okay. Let's submit this and check if it gets accepted or not. It should get accepted ideally, so you can see that it clearly gets accepted. Now talking about the time complexity of my code, so basically guys, the time complexity will be order of n, because we are iterating through each and every node exactly once. For a particular node, for storing its subtree, first of all I'm calling on the left subtree of it, I'm getting the left subtree data, then I'm getting the right subtree data as well, and I'm generating the key as left subtree plus hash plus the right subtree plus hash plus the current root data, okay. So time complexity will be overall order of n. Space complexity will also be order of n, because I am running a recursion, and in the worst case, if the tree is skewed, then the recursive stack space can be order of n, as well as we need to add order of n again, because we are using map data structure as well in order to store all the subtree informations or the subtrees in the condensed format of strings. So I hope that you have understood this problem clearly. This was previously asked in Amazon. If there are any doubts, you can mention them in the comments and I'll try to answer them as soon as possible. Thank you for watching this video guys, and keep coding.